Hello everyone, I'm Ken Hanson, a professor in the Department of Chemistry and Biochemistry at Florida State University, and this is a video abstract for a recent publication in the Journal of Chemical Education entitled Generative AI versus Student Performance on Multiple Choice General Chemistry Exams, Insight into Question Design from Regression Analysis. And so before diving into the actual paper, we have to give a little bit of history behind this process, because this has actually been a 10-year journey in understanding and making exams better. And so, looking back at our original effort, it started almost a decade ago. And this was in 2017 when I started to do test analysis. And the idea was to use Roche analysis combined with classical testing theory to analyze and make exams better. And so, across three semesters of data, we did that. We improved our exams progressively. And then COVID hit. And so in fall of 20, we were forced online, and online was a major change in how we administered tests. It went from, multiple choice in-person bubble sheets to doing online testing on Canvas. But this did provide us with an opportunity because even when COVID was gone, we could still do tests online. And so the idea behind this next study was to compare in-person and online exam performance. And again, looking at all the metrics associated with them and analyzing how the outcomes changed. And interestingly enough, we didn't see a major change in student outcomes or abilities. Also, we saw very little evidence that there was an increased prevalence of cheating. And so if there was cheating, it was not statistically obvious in those online tests. But one of the reviewers for that particular paper had an interesting point, and because it's close to the end of fall of 2022 was when generative AI really started to take hold. In fact, ChatGPT, the original was released on November 30th of 2022. And so that's an important question because all of a sudden it made cheating much easier. But it also raised questions for us. What would it look like if two students did cheat using ChatGPT? And so what we did is we took all those exams that we previously administered and we fed them into ChatGPT. And so when we started doing this study, it was ChatGPT 3.5. And what we did is essentially put in the question, took the single letter answer, and we compiled those responses. And so we did it 6 times for every single question, and we just wanted to look at what the success rate was per given question. And so interestingly enough, when you give all questions to ChatGPT 3.5, they were below average compared to students. And so here are the students' average for the exams in spring of 2019. Here's the ChatGPT averages. But when you did text-only questions, keep in mind ChatGPT 3.5 couldn't process images. When you did text only, you saw ChatGPT was on par with students, or maybe a little bit below average on some exams and a little bit above average on other exams. But the point was we couldn't use the test average to determine if a student was using ChatGPT because it just looked like an average student. And so we turned to Roche modeling. And so Roche analysis basically says the probability of success on any given question is related to 2 parameters, student ability and question difficulty. And so for every question, you get a graph that looks something like this, where ability is on one axis, probability of success is on another axis. And as a student's ability goes up, so too does their probability of success. As their ability goes down, probability of success goes down. And so you can do this fitting for every single question across the entirety of exams. And so when you do this fitting, you get a graph of basically question difficulty versus student ability and something called a right plot. And so again, we see here's this distribution of student abilities, and there's ChatGPT on the gray line on all questions. And on the text-only questions, you can see ChatGPT does a little bit better relative to the still student ability distribution. The take-home is we can't just use, the ability of ChatGPT to determine success rates. And so what we looked at next was per question outcomes. And it was really interesting because sometimes ChatGPT does way better on students, for example, question 1, whereas question 2, ChatGPT gets completely wrong and students have a 75% success rate. And so what this basically told us is ChatGPT, despite getting an average score similar to students, is not behaving like a student on an exam. And so what we started thinking about was the fit. And so in this particular model, the assumption is that, students in general, high-performing students are high-performing, they get hard questions right, and low-performing students get hard questions wrong. But this effectively tells us ChatGPT doesn't behave like a student. Instead, ChatGPT is kind of an outlier on this particular model. And so what we started to look at was the outfit statistics, saying, if they don't fit the model, then they're going to have this statistical outfit, which we call, in this case, we use the standardized outfit statistic to start looking at and discovering when a student might be using ChatGPT. And so here's one example. I think this was the spring of 19 2019 exam 1. And here you can see this histogram of outfit statistics. The students generally fall in this range right here, whereas ChatGPT falls significantly out of that normal distribution range. In fact, if you wanted to set a detection threshold for ChatGPT, perfect detection threshold, you get about 2.1 false positive rate, where these students here kind of look like ChatGPT, and it's hard to tell the difference. And so it's pretty good at detecting students. And so we did this across all exams, fall of 19, fall 20, fall 21, fall 22. And here you can see exam 1, 2, 3, and the final. And the take-home message we had is it's pretty good at detecting students. And so if we wanted to set this true positive threshold, we get a relatively low false positive rate. And so less than 10% on basically all exams. If you do the receiver operator curve and you look at the area under the curve, turns out this is a pretty good detection method. 18 out of the 20 fall in the outstanding category, whereas 20 of the exams fall in this excellent category. And so we were pretty good at detecting these outcomes. What was not obvious to us at the time is some detection or some exams it's better at detecting than others. And so really this led to one important question: is what causes the difference in per question outcomes, right? Is it the content? Is it the format? Is it the number of words? And so that started us on our next journey. And so in this particular paper, we try to answer that question. And so what we did is we took all those exams across the 5 semesters we were looking at, 930 questions, and we effectively classified every single one of those questions. And so here you can see just an example spreadsheet. We looked at what chapter, book section, whether it had diagrams, did it have equations, did it have tables, figures, was it a 2-layer question, did it have numbers, did it have calculations, was ordering, did it contain not, bold, italics, caps. And so just as an example, here's one particular question. And so when we look at this question, the item stem has 33 words, and then you can look at the answer option. This would have 2 words, this would have 3 words. This is a type K format because it has 3 options here, and then you select from those. It's chapter 12 content, in particular sections 12.2 and 12.5 of chapter 12. Under the Bloom's or revised Bloom's taxonomy, it falls under knowledge type B and knowledge subtype BC, and cognitive process 4 and process subcategory 4.2. And so again, we did this for every single question across these 930 questions. Anything that didn't fall into these categories, we just marked it as a no or a 0, depending on what the indicator was. And so from there, we took all that data and we did this binomial regression analysis. Basically, fit it with the linear equations and find out which variables matter and how much they matter. And in this particular case, we care about impact to odds. Basically, what's the likelihood that a question success goes up because it has this parameter, or what's the likelihood that a question success rate goes down because of a particular parameter. And we set our p-values to less than 0.01. We wanted 99% confidence that these particular variables matter. And we also got rid of anything that was collinear. And so if there's a correlation coefficient greater of 0.7, we took the parameter that mattered more of those 2 correlated variables because they were maybe describing the same thing. And so ultimately we get an output that looks something like this. And so on your y-axis here we have impact to odds, and on the x-axis here is all the parameters that mattered for student performance. And so we took the student performance and said, when all things are equal, which one of these parameters impacts the outcome, and does it increase or decrease student performance? And so over here in green you can see things that raise student performance, and over here in red you can see things that decrease student performance. And so some examples of raising student performance: if a question had a table, the likelihood of a student getting it right increased most out of all these parameters. Likewise, fill in the blank, they had higher success rates. And then other things like capitalization, does it contain not, equation, parentheses. In contrast, if the questions fell under knowledge type CB or CC or CA, student success rates went down. And so likewise, if it had all or none of the above, student success rates went down. And so we did the same thing with ChatGPT. Which parameters make ChatGPT better? Which ones make it worse? And so you can see the increased performance for ChatGPT. The biggest increase was for questions containing not, like which of the following is not, and then things that contain tables, parentheses, equilibria, and then things that decrease ChatGPT performance, again, knowledge type CC, cognitive process 2.1, so on and so forth, equations, capitalizations, if it contains an underline, performance of ChatGPT went down. And there were some consistencies across both students and ChatGPT. One that was interesting, or we found interesting, was there was no statistically significant correlation between the rates of success and the chapter numbers. So it wasn't a case where students were very good at chapter 14 and not good at chapter 12. There was no statistically significant correlation with chapter and success rates for either students or ChatGPT. Interestingly, for both as well, every time the word count doubled in the stem of the question, there was a 10 to 15% decrease in the raw odds of success. And so we don't necessarily know the cause of it, but it was consistent across both ChatGPT and students. And so ultimately, we wanted to know what differentiates students from ChatGPT. And so we looked at this delta ITO, or delta impact to odds, how much it changes between students and ChatGPT. And the statistically significant parameters are here in this graph. And so this one's the big take home. In green here are the ones, the parameters where students performed better than ChatGPT. And then over here in red are the ones where ChatGPT performed better than students. And so some of the take-home question, or some of the take-home messages, both students and ChatGPT increased their performance when not was included in the question. But ChatGPT was better at questions that contain not. In fact, it was twice, the odds of success were twice as high when the question contained not for ChatGPT relative to students. Likewise, the number of book sections, so not necessarily the topic of the book sections, but the number of book sections that a topic covered, it decreased the odds of success for both students and ChatGPT when more sections were covered, but less so with ChatGPT. ChatGPT did a better job than students when multiple sections were contained in one particular question, or one particular question. And so it could be something, an equilibrium question that also ties in rate constants. And so two different chapters, two different sections covered. The most advantageous for students were cognitive process 2.1, which is interpreting, and then cognitive process 2.3 as well as classifying was better for student outcomes, as well as equations, capitalizations, underlines. These are potentially just things that emphasize that ChatGPT doesn't necessarily recognize, but a student might recognize as being important. And so, conclusions for this particular paper. These outcomes reaffirm that ChatGPT thinks differently than students. Thinks obviously is in quotes here. It just says, the outcomes of students versus ChatGPT are different, and they do have something to do with question formatting, not just topical content. One could envision using this information to design items that could mitigate for cheating. Like if you're concerned that students are using ChatGPT, you could target particular categories that are better for students than they are for ChatGPT. One other thing we found interesting, and this was after the fact, is this could be expanded to online surveys where you want to differentiate between human and generative AI responses. And so this is particularly important in sociology, where if you're doing an online survey, typically you'll see a question that says, click C to this particular question. And that's a way historically they've used to mitigate for people just clicking random answers. But now ChatGPT and generative AI can answer those specifically. And so can you design questions that trick it, or you can identify generative AI use? But there are also fundamental limitations with this. And a big one is it's difficult, if not impossible, to suggest why these differences exist. And so talking about causality, generative AI is largely a black box. It's predictive text. Why it does certain answers or why it doesn't deal well with certain things, that's a complex problem we can't necessarily answer. Also, inherently problematic to this is any method you develop is competing against the rapid evolution of this generative AI technology. And so new technologies, new generations, new training sets change how it responds. So there's not going to be a catch-all, and if you have one, it's going to change in months anyway. There were also no variables that were completely successful at stumping generative AI. We would have loved to have found a scenario where if the question contains all of the above, for example, ChatGPT always gets it right or always gets it wrong, and that's simply not the case. There was no catch-all parameter that we got to specifically identify generative AI. And the other issue is this study was particularly focused on ChatGPT 3.5, which is what we were using at the time. There are many different generative AI engines available, and the characteristics for each of those each one of those engines will be different, and the variables that impact it will be different. And so the logistics of actually using a methodology like this to either identify generative AI or trick generative AI is going to be inherently limited by the accessibility and plethora of available engines. And so if you want to read more about it, there it is. There's the reference. I'll have have the reference in the comments as well. Journal of Chemical Education, 2026, Volume 103, Issue 2, page 872. And so with that, I'd like to acknowledge Florida State University for letting me do this study, getting IRB approval and all sorts of things. Shout out to Benjamin Sorensen, longtime friend and collaborator on all these studies. He's the one that does the rigorous statistical analysis of all these outcomes. Students involved in the work, Grace McLeod, Ben Hanks, Hannah Ashby, and Jackson Nolder. They are the ones that went through question by question and filled out the characteristics of those questions. Also, shout out to the teaching assistants for all those 5 semesters worth of classes. They helped generate questions, proofread the test, proofread the questions, so we really appreciate their contribution and effort. And so with that, I will close. Obviously, you can't ask questions to a video, but if you have questions, you want to put them in the comments section, or send me an email, or check us out on Twitter, Instagram, and our YouTube channel as well. And with that, I will close.